Hello, and welcome back to another episode where we are recreating Baldur's Gate 3's camera system inside Unreal Engine. Now, in the last episode, we managed to fix up a few bugs that we had with the system regarding the shadows being called out, as well as adding some noise in and around the occlusion effect that we've got. As you can see, it's looking very nice right now. It's already at a stage where you could almost consider it done, but there's still a lot of steps that we have to go, including one that we see right here. We've got another bug to fix up where if you're flying through the world, the camera kind of jitters when it hits all these walls. And the reason why it jitters is because of the system that we've already got set up to adjust the camera height, right? So it's hitting these walls and seeing it as an obstacle and leaping on top so it's not being blocked. Now, this isn't something that we want for walls or environment actors generally, but it is something that we want for the world bounds and like a landscape, because generally we don't want stuff like this happening where it kind of hits the landscape and goes underneath it. We want that logic to be the absolute minimum that the camera can get to. So how do we fix that? The way we're going to fix it here is we're going to add our own collision preset to this project that allows us to single out the environment actors and make sure that the camera doesn't clip through them or doesn't collide with them. However, the character still, can't walk through them, of course. So the way we're going to do that, we're going to jump in right now, is we're going to go to Edit and Project Settings, and I'll drag this from the other screen, and down to Collision. Now this is looking fairly empty at the minute, of course. You can open up Preset and you can see all the collision settings that Unreal has by default, which you might notice as well if you load up a static mesh. If I click on one of these, for example, and scroll down to Collision. In Collision Presets, you can see it's got all these collision settings, collision profiles, which are the same here. So we're going to add our own. The first thing that we want to do is add our own custom object type. And we're going to click on New Object Channel and name this Environment. And we will leave the default response as block. This basically means that all the traces and all the other methods of colliding with it basically by default will always be blocked by this channel. And to use that, we're going to set up a new preset and we're going to call it the same name. We're going to call it Environment. We are going to enable collision. So collision enabled. We'll do queer and physics. I think we need both of them. In the object type, we're going to choose the environment that we just set up. And we'll describe it something like actors that we want the camera to be able to pass through, but not anything else. And to make sure that the camera doesn't affect it, we can make sure that the camera trace type is set to ignore. So everything else will be colliding with it, but the camera trace specifically will go right through it. And that's the trace that we're using to adjust the camera height. So if we hit accept here, and we can now close the project settings and go back to our level, I can select all of these. Let me just select them all from here. And in the collision presets, we can now choose environment. And if we hit play now, you'll notice that it's going right through the walls, and that problem is sorted. So that is beautiful. Cool, now that that's sorted, the next step that we have is to sort out dithering. I keep bringing up that word, but what exactly is it? Dithering, in terms of rendering, is the process of basically faking translucency for values between 0 and 1. Generally, you're either making something translucent or masked. Translucent has all those values between 0 and 1, and masked is either 0 or 1. Dithering is using the masked method, meaning it's a lot cheaper, but simulating that whole range of values between 0 and 1, basically between opacity and transparency. And I'm not going to get into how it does that. You can look that up if you want the specifics, but we're going to start setting up some base classes to utilize this method and kind of give us that effect for fading out entire rooms. What we want to do is, for example, if we are on the base floor of a house, we want to be able to call out everything above that floor so that we can see everything that's available only on this floor. We don't really care about other floors until we get to those levels, right? And the way we're going to do this is we're going to set up a new blueprint class. We're going to make it an actor, and we're going to call this environment actor. I always struggled spelling environment. And if we load that up, drag that over, I'm going to stop the simulation just before I forget. We are going to add a component, and this is going to be a static mesh component. And we're going to make that the default scene root. And in the mobility for that static mesh, we're going to make that static because we don't want environment actors really moving around. And this kind of just speeds up the rendering process. And to speed up other processes, we're going to disable the tick because this is kind of just, we're simulating a static mesh actor, right? So now that we've got that, the next thing that we need to do is add some logic that we want to happen. What do we want to happen? Actually, I'm going to make this a blueprint interface. And I'll explain why in a second. But I'm going to call this, what do we want to call this? Transparency settings, something like that. We're going to preface it with BPI for blueprint interface. And actually, before we forget, we're also going to do that for the environment actor, BP underscore environment actor. For the transparency settings, what we're going to do here is add two new functions, fade in and fade out. And also, let's add a way for checking whether it's already faded in or out, and we'll call it is faded. And this one is going to output a boolean that just says if we're faded or not. Let's use proper naming conventions. Cool. Compile and save that. And now in the environment actor, we can include that interface. So if we go to class settings, we can go down to interface, implemented interface add, and we'll grab BPI transparency settings. Compile and save that. And now you'll see in the side it's got is faded, fade out, fade in, and we can start implementing some logic for that. So if we right click and go implement event, we'll do the same for out, and we will do the same for is faded. We'll open that. This one is a function because it returns something through the interface, and we're going to make a variable called b is faded. Oh, we can't do that here. Shouldn't be a local variable anyway. It should be a normal variable. Be faded. Why not? Plug that in, and all this function does is returns if that's faded or not. Now, in the event graph, we are going to set this up in a second, probably in a later video actually, because we're not going to worry too much about that right now. But in the static mesh, one thing that we also want to do is make sure that the collision preset is set to our environment that we set up. We can compile and save that. And yeah, what do we want to do now? So the reason why I'm setting it up in a interface rather than just in this blueprint is because although we have this logic working on the environment, we might also want to include it on, for example, characters. Say an NPC is wandering through the level, and we'll use the example from before. You are on the ground floor, and there is a floor above you. If the NPC wanders up to the second floor, we still want this dithering effect to happen on them as well as the environment, right? So as they go up the steps, they'll start to fade out. And if you follow them in, they'd start to fade in again. So that's why we're using a interface, so we can kind of have this logic across all actors. But the reason why we're setting up an environment actor is because this is going to be our parent class for just basic environment actors. And we're going to make a standard one here for pretty much what we've already been setting up, just these walls. I'm going to make a new... I probably shouldn't have done that in the camera folder, but... well, we're working in here now. Let's go new folder, environment. And I'm going to right-click on our environment actor and create a child blueprint class. And we're going to call this BP wall, something basic, because in the tutorial we're just going to be setting up basically what we've got here. However, you may want to add environment actors for various, actors that you've got. You could say do it for tables, doors, chairs, paintings, everything. So I'm going to move the BP wall into our environment folder, load up the actor, and I'm going to set the static mesh to, I'm just going to copy the settings from here actually. So if I find where this cube is, it's in Engine Content Basic Shapes. I am going to just use that selected asset, bring it in here. And importantly, we're also going to set the material to what we've been using, mm_environment. Of course, your actor might have something different. You'll notice that it's kind of hard to look at in the editor just because that effect is already being applied to it, but we will have some logic later on to sort out that effect as well. So we will drag that over, and what we can start doing now is if I find that actor that's just got on my other screen, but all I'm doing is hitting browses to the associated asset, just that there, to find it in the library. I'm going to select all my cubes that we currently have in there, and I am going to right click, replace selected actors with BP wall. And hopefully that keeps all the same transforms and everything. Yep, that's perfect. Cool. So it doesn't look any different. It's got all the same logic going on, but now it's using the environment actors that we've got. And now we can start setting up that dithering logic. So in the next episode, I'm going to basically quickly build up some, like a house for testing purposes. And we can start getting into that fake transparency or the entire room fading system. So yeah, I will see you in the next episode. Have a good one.